and some people also from Berlin, right here. Who else made it a long way here? From where?
2 hours.
2 hours, okay.
3.5 hours.
3.5 hours, where from?
Zwickau, Chemnitz.
Okay.
It's between Berlin and Munich.
Oh, wow. Okay, so between Berlin and Munich. So thank you for making the effort. I'll definitely be around for questions and answers, especially those that drove such a long way. Please make sure you come and talk to me to get everything answered that you're wondering about. So this is a presentation that's meant to kind of introduce people, but also shock people what the impact is of event modeling, because I didn't anticipate that it would be such a transformative approach when I started. I just thought, you know, this is what I would do if I was putting together some systems, and if it was up to me to program them, this is what I would want. Yeah, so I've been programming since 1983. It just makes me really old. But I started on a Commodore 64, which I think was also quite popular here in Germany. I know we had a lot of pirated games in Canada from Germany that we traded as kids. That was kind of my inspiration to program, because I always wanted to make my own game, or to break the copy protection on a really good game, right? So those were driving factors, I really liked it and stuck with it throughout my school years. And before I was out of school, I started to consult and just help people digitize their offices, etc. I always worked around computers. I stepped into the enterprise, Dilbert office world of IT departments in the late 90s, and started to look at different better ways to build enterprise software, which for some reason looked a lot more trivial than the things I was trying to do, learning machine language by myself as a kid. So I got kind of inspired there, because it seems a lot of people were getting paid a lot of money to do things that were way easier than what I was doing. So I was definitely doing the wrong thing. And so around 2000, I started to look for better ways, and that's when I started to explore extreme programming and Agile and UML. I got full training on all those things, even really boring things like PMI and PMP and all those things, right? So I really wanted to understand all of the things that made larger organizations work. And then in 2008, I started to work on event sourcing only. I was a person of extremes. When I found extreme programming, the name was quite fitting, because that's all I wanted to do, and I wanted to make sure that wherever I worked, I was pushing the envelope for the organization to be better. I didn't like to see waste or things done incorrectly. I didn't like to. I was a bit of a perfectionist when it came to programming. It's actually due to this. We were poor immigrants, so I was actually born in Poland, and in 1983 we emigrated to Canada, and unfortunately my parents' degrees didn't transfer, they didn't have the language, and so they worked odd jobs, and we were quite poor. So when I got my Commodore 64, we didn't have money for a disk drive or a tape drive, so I had to type in my programs every day after the power went off. So I learned how to type, and I learned how to refactor code without tests on paper. That's good training for the future. Event sourcing was another one of those things, because once you, just like discovering Agile and extreme programming, you see an advantage. You know logically that it's better, and then you see resistance from people that are just working on their regular day jobs, and they are quite happy to do what they did yesterday, and they want the same paycheck. So we all have these issues, and most of the time it's because of people that are not at the meetups, right? They're the people that want to do the same job every day. So we always have a problem pushing things forward. Event sourcing was that for me, and I remember I think you asked me earlier, what was the aha moment, that on all these things, and for event sourcing, it was really understanding like mock objects and dependencies, how traditional approaches needed way too much hand-holding with frameworks and mocking libraries and things like that. When I saw if you just focus on information flow, how something like event sourcing could have just simple POCO or POJO classes that embody just the data in some sort of a structure. They can also communicate actions and all the things that you want and intents in your system. So I had about 3 months of unlearning all my extreme programming and test-driven development stuff to start to look at more honest ways of doing that. So event sourcing was part of this. I wrote my first event store in 2009, which is still in production. It was about 1 page of C# code that just wrote into continuous files. Let me see, sorry. Just gotta double check that I don't have a power issue here again. So yeah, that was pretty interesting. I struggled for 7 years trying to be a consultant that wanted to do things the best way, because in those years, trying to do event sourcing in any company, you were pretty quickly escorted out the door. You can't do crazy stuff here. No one knows what you're doing. This is not standard software development. But I found the projects as a consultant where I could be the only IT person there. I also found some like-minded people. So through community events like this, going to conferences, speaking about these topics, meeting with people that were also doing the same thing, really gave me the strength and the knowledge to build on it and persevere. Whereas I think a lot of people in those years maybe did some kicked the tires and said, oh, event sourcing is cool, but it's not for everyone because everyone is still doing CRUD and all these things. But I was stubborn, like with anything, like with a computer with no disk drive. I continued, no matter how hard it got. What I realized in these 7 years, though, that I could only get so far as a consultant. I could not go much further. It was always the inertia of the upper management and the directors and the other tech leads. And all of them had different opinions about whether to do this at all or how to do it. And so it was like trying to move forward, dragging a lot of weight behind you. So I really wanted to be much more proficient and have my skills all the way over here. And I knew that I had to develop all these different things and do all these practices, but every time that I tried, I had to bring along someone else or convince someone else or whiteboard something for someone else to spell things out, or change jobs because it was a dead end and do it all over again from the start in a new place. And in 2015, I said, okay, I've gathered enough people that want to do the same thing, I think, but I'm going to do it anyway, and I'll start a company that only does this. And surprisingly, people quit their jobs and said, okay, where's the project? I want to do the same. Okay, well, I better quickly find some clients. So that was my next challenge, is to actually find work to do. And it wasn't too long before I found some projects. This was a turning point in my life as well, because I could go definitely that CTO route in some really successful companies. I turned down jobs that were paying $250,000 as a CTO or more, and I knew what that was going to be. I was going to maybe have a chance to direct something, but it was always under someone else's wishes and someone else's dream, etc. So I said to myself, I better do this from the ground up and build it as best as I can without any compromise, without any handout of a large paycheck. Because once you start getting paid that money right away, you start to have a compromise yourself with your morals. How do I support my family and all this? Or do I now quit my, cushy CTO job where now I can afford a better house? So I know I didn't want to get distracted by that. I wanted to build every single penny on doing things without a compromise and only do it that way. So since I was only doing this since 2008, I had enough experience to do it, but I didn't have an experience of leading a company to do it. And so this ended up being a very interesting journey. It had some incredible impacts I've never seen before. I never really had to do any interviews. People self-selected by different things like getting paid by fixed cost, only doing event sourcing, etc. People that waste your time don't show up to that. So by having a high standard, doing something a specific way, allowed me to do some interesting things. So anyway, that's a bit of the history. And it was quite a struggle. It took a lot of belief and stubbornness and perseverance, a lot of arguing on Twitter to do that. So what is that problem that I saw? When I started out, I needed to build systems for organizations. They were now my clients that trusted me to say, okay, you have the space now. Your organization can build everything up and down. So what was the problem? Notice that we had visions and goals in any organization. You might have something like Uber that says, what is our vision? It's to make transportation easier in the city, right? One sentence or two sentences. And then from there you have goals. You must know how good your driver is. You must know where you're going. You must get the best rate. You can have 5 or 6 or 7 goals that your organization will fulfill in order for it to be valuable and exist. From there you start to break things up into like, okay, what are the requirements? Right? What's the architecture? How many subsystems do we have? In the example of Uber, we might have a driver passenger matching system. We might have a rating system. We might have a pricing system. We might have another system for something else. Then we have your tests and code. You can flip those, but you're getting into a lot of work and a lot of people by this point. This is just the CEO, right? The founder. So I sort of see organizations formed around this distribution of where the communication is and what type of information flows at these different levels. The one thing that's important is there's something right here in the middle that joins both sides. The people that are technical, that want to know exactly how things go, they can follow how a system changes state and use things like systems thinking. But so does the CEO and all the directors and management. They also want to know that in some workflow that the customer got the car they should have gotten. They can track that with the state that the system went through. So that was kind of a realization that I needed to come to, because if I was coming to clients and insisting only on doing tests and things like this, I would miss out their vision. And if I was coming in with very vague user stories that weren't specific enough, I would lose the connectivity to actually executing those things. I needed to really focus on this. This was from kind of an insight from Fred Brooks that really said, if you just see, what the data is in the system, what's in those tables, then you'll understand what's going on if you examine the data. You can look at code or flowcharts and you'll keep guessing, even if you're technical. But state is the thing that communicates things really well. So I needed to track how state changed. That was a very fitting thing to call them events, because in a systems thinking way, I can say that this information was not in the system yet, but now it is. It crossed the boundary. Someone hit a submit button, and no matter what your tables are, if you're doing event sourcing or not, this event happened in time. This external information is now internal to the system. It's on the disk somewhere. We also needed to be able to present state. And the problem with capturing state with events is that it's too granular. It has to be refined, massaged, and processed to make sense. A classic example of event sourcing is the shopping cart, people adding different things, people taking things out. But at a certain point in time, you say, what's in the shopping cart? You have to consolidate all the things being added, all the things being removed to understand what's in there. So that was a necessary thing. And we also needed to show intent, because some of those things that we wanted to put into the system could fail for business reasons, for being out of disk space, for network connectivity, but we wanted to have a place to show on a diagram in documentation that we actually have a place for things to get rejected. And the last thing that we added is screens and processors, and I think this is one of the key differentiators between UML and other things with event modeling. I haven't really seen a methodology that embraced user experience and UI design as much as event modeling does. Yet it's part of building all systems. Like what humans look at is quite important. Systems are built for people, for them to accomplish their goals. And when I was starting out, I didn't have, I only had myself and maybe one other person at the very beginning. So I couldn't hire a UI person. I couldn't hire a project manager and all those other roles. So I needed a way to have all of this done together as quickly as possible. And I was able to show that it's possible to put in the UX and UI concerns into the specification, into the design of a system in event modeling. And so then we just had to arrange them to make sure that we knew what subsystems to build, what happened next, to talk about user stories, user journeys, epics. All of these things had to not just be words written down in text, which are hard to follow. You wanted to have something that could be traceable. So it kind of goes back to how would you show your friend how your system works? You kind of sit them down on a chair beside you, and you would start to explain the system as you logged in, did a few actions. You would explain what the information was that you were typing in. You would explain any of the impacts, but you would continue to go through the example of using the system. And after a few screens, you would probably get to the final one where you either purchased the product, or if it's Uber, you completed your trip, and now you finished rating your driver and giving them a tip. So, if you're explaining Uber to someone for the first time, that's kind of what you would do. So we simply captured that. I mean, already we saw people using event-driven approaches, but without all the other stuff. A lot of this kind of journeys through events were done simply for back-end systems to say what information comes into the system at what time, but that's it. It was quite anemic. I needed to also have the client sign off on, do these screens look okay? Does the interaction of these two users make sense? Do we need to have 3 subsystems? All these kind of questions could be answered. Do we have a place to describe some of these things? So we really needed a blueprint that was very similar to a blueprint that you have on the construction site, where everyone can go to this blueprint and do their job. Like in a construction site, the plumber knows where to cut the holes and all of these things, like where the carpenter will cut the holes in the walls. All of the different roles that are involved in building a house, they can have a really large blueprint that's out on a table on the construction site and coordinate with one another. And this is kind of what we were missing to build software reliably and without stepping on each other's toes, and also to dissect the different units of work to be more or less the same on average. And so looking at that middle part of that triangle that I showed you, state, kind of gives you that. So it wasn't components like classes or methods. It wasn't something higher up like user stories that were written in text and not really dissected for individual steps through state transitions. That was too technical for non-technical people. So we needed that same essence that could be done by non-technical people, yet serve technical people to their satisfaction. The other thing that happened is that we could distribute work across this. Since we were doing event sourcing, we knew that we had very low coupling with all of these. And we also had a very good single source of truth. In traditional systems, that's a whole entity relationship diagram where you have to argue whether your tables are constructed correctly, and then the entities that are populated with them, you have this fight with each other to say, no, the order should have this, or we should have, withdraw and deposit on accounts instead of transfer. You have all of these subjective arguments. I have more experience and I have my computer science degree, so I'm more right than you are. There's very subjective ways of doing that. What's nice about events is that no one can argue. At that point in time, that information entered the system, right? So I'm not even talking about designing the events, because if you look at it from a UX, UI perspective, kind of the best experience for the user to put that information into the system at that time is the best decision. You're there to serve that. It's not a technical decision. Now you have to deal with that the system captured this information. If you make that decision, the whole organization can say, I have a source of truth that's unbiased and undisputed. It's okay to be tightly coupled to something like that. It's bad to be coupled to something else that's subjective, which is the way you interpret the previous steps. So this is called slices. Other approaches also use slices, which means you're doing full stack development, UI all the way down to persistence. But what we found is that we got a lot of autonomy here. In other words, a developer that was working on this piece here was totally free. Oh, should probably change my timeout on that. They were totally free of the work that was being done here. They weren't going in the database and asking if they could change the schema because another developer might be affected. So these pieces are purpose-built for just moving the process that one step ahead. And that level of decoupling was quite powerful. We stopped seeing the problems of the two pizza-sized team. Like in Agile, you talk about teams never being bigger than what you can feed with two pizzas. This could scale infinitely. There was no coupling to worry about. The pizza-sized team is the problem of having to always make sure you're not stepping on anyone's toes. So if you have 5 people, you have all these permutations to talk to all of them. The minute you add a 6th person, it's even more. It's this exponential blow-up of how much communication you have to change something in the system, or even implement something in the system. So this looks good. It's like a story. It's like also a storyboard for a movie. At the top you have the scenes, here you have the plot. Has to make sense. If the plot is bad, you won't have anyone enjoying the movie, you'll get bad reviews. If it's ugly, same thing. So yeah, both things are quite important. Also, a lot of people are visual learners, so they would focus on the top of the diagram looking at the data that's exchanged. Now, this is not a complete event model because we have actual properties and example data that you can trace through. It's another point of this. Tracing the data is quite important. It's saved a lot of projects because a lot of requirements assume bad things, like the fact that I have some data when in fact I don't. Because they're usually written in text form. Use cases and user stories. The good ones will usually have an area at the very bottom where you're talking about related or associated user stories, and you as a developer are meant to go and check those to see if there's any problems in terms of coupling or things that they'll have to have in common. But that is a very manual, unintuitive, high sort of requirement of the developer that never really happens. Here it's visual. You can actually see the connections, and you can follow on the complete model something like an email. You know, if it's entered here, you can see exactly where it's used further on. So you can see whether you've made an assumption. Maybe you see some data here that is nowhere else to be found. So you can start to go back to the business and say, you're making an assumption that we have the exchange rate already in the system, but we actually never made a call to get that exchange rate or something like that. And that's what kills projects, is bad assumptions. So this allowed us to do really good initial pass-throughs and then rescue really large projects out of quite serious trouble. There was a trading company that had to switch from a Windows-based system to a web-based system, and they're actually responsible for 10% of the world's trading traffic. Their customers are Reebok, Procter & Gamble, all the top Fortune 50 companies. So I was impressed that this approach actually allowed them to fix 2 failed rewrites, and the third one was going to kill them. It was one of these missed things. They tried event storming and domain-driven design, and they were doing all the right things, except for event modeling. They haven't tried it. When they added the event modeling piece, they saw on the second day of the workshop exactly which piece was missing and why it was ignored. And the people that were looking at that particular part of the system, you know, what type of specifications they were used to. They were Harvard educated, very traditional. And even through all that, they missed some of these things. So this whole thing about having example data, it's essentially as if you did a screencast of that Uber and just later on paused every time the screen changed and put it down there and then wrote down below what the data was and where you think it was in the system. That's essentially all you're doing. The reason this works is because humans like to imitate and copy. When you ask someone, how does Uber work? Did I write down paragraphs for you to read? No, I showed you Uber with examples of how I use it and explained with real data what's happening, right? Relatable. So this is why this format is highly effective. Now there are exceptions and permutations. So like an invoice might have a different amount if there's a discount applied, if the taxes are different, if there's a tax exemption, if there's a volume discount. So an invoice doesn't really change the flow of what the user does, but there is a difference of data that can happen. We show these in these specifications down below the event model. So if there's an invoice somewhere here, we would say, okay, the invoice can look like this, like this, like this, or like this, or like this, as we, first of all, have no events, then we have this event, then we add yet another one, then we add yet another one, and at the end we have 4. So we have 5 test cases here. We can show in each test case how that changes with the extra data. So we might apply a discount, or we might actually add an item, add a discount, add a tax break, add a volume discount, or something like that, and show exactly what's happening here. We can reuse some of the event history here for more tests if we want, but this is as concise as we can make for some of the data permutations that we have. Bigger problems, like in a trading system, when something goes wrong, you can't just undo or show differences in data. You have to go to another section of the event model and see how you unwind your trade. There would be totally different steps. And so you make an arrow from the middle here, put it to some other area of the event model and say, this is what happens when you need to back out. So I already touched the slices here about how we work. Each developer grabs a complete vertical slice and implements. Because you have real data and you have the schema of the data, these become really good preconditions and post-conditions for how a developer uses things to be written. So if I was to write this piece here, I would really understand what I'm relying upon here as my preconditions and possible values that I would have to take care of, and I can implement that. I'm also quite aware of what I need to leave behind so that the work that others do, or myself, from here on. So these contracts on either side of each slice are quite powerful. It allows people to click the whole solution together like Lego bricks. And so we've been doing this aggressively for 8 years with incredible results. These end up being the same size, pretty much, on average over many projects. So we're quite happy to do fixed costs on this, which really gives, de-risks a lot of projects for everyone.
Adam?
Yes.
One question before you
Sure.
move forward. So you mentioned that this tracking company, they use event storming as well. And that is pretty similar, isn't it? You also have events when you model things.
Yes,
Why did it fail?
Event storming doesn't have this rigor of showing information completeness. A lot of people that do domain-driven design and event storming, remember the initial event storming exercise that Alberto Brandolini popularized was really the value of having everyone in the same room to discuss the domain boundaries and the ubiquitous language and come up with the organization overall. So that's not enough to give developers concrete units of work, more or less at a granular level that makes sense, like a granularity that makes sense. So we've had a number of clients that, now the work is not wasted. Like they came up with really good names for the events, etc. They just can take the artifacts that they produced and instead of putting them in the corner like the initial event storming sort of methodology prescribed, that the event storming was really about the value during that day, and then you roll up the paper and you put it in the corner, you don't revisit it. The value was the interactions, the collaboration, right? What this does is that it does the opposite. It says that collaboration is useful, but it must be put into some format so it can be translated to actual work. So that's what was missing. Especially if a lot of, like, there's no real, this has a bias towards event sourcing. There is no bias in event storming towards event sourcing. In fact, in 2018, at the Event Storming Summit in Bologna, most of the event sourcing community, the community leaders, downvoted anything to do with event sourcing or CQRS. There were red and yellow stickers, we don't need to talk about it. So event modeling fills that gap. The intention to, the idea that the easiest thing to do is event sourcing is one that we stand by. It's the most responsible thing. It's really about treating information systems like accountants treat money. It's additive only, there's no erasers. You have to be accountable for what you put in the system, and you have to have a breadcrumb trail of how you got there. That is why we will never build a non-event source system. We only build event sourced systems for 8 years straight, personally for 15 years straight. That's a decision that I made, and I'm happy I did, because it's every single project is free of about 100 different problems in software. There's no data migration issues with, yeah, I mean, I have horror stories from traditional projects where you have to map data from a previous schema to a new schema where it was almost impossible to do. And I never want to work like that again. So event modeling definitely has key differences, both from the mechanics of it to also the intentions and purposes of both practices. And in fact, in 2018, I came to that summit assuming that I was doing event storming better than Alberto. And of course I was wrong, because it wasn't event storming, it was event modeling. So I gave it a name and here we are. And event storming is still its own thing, but it has a different purpose. It was built for with a collaboration piece as the core driving force. Here we do have collaboration. It's nice to talk to everyone about what's going on, but the key driving force is to produce something that will guide your project all the way through to building it and maintaining it forever. We come back to projects we haven't touched in 4 years, and we implement a new feature that day. There's no ramp-up time.
So is it like live documentation that you would maintain forever as soon as you created it?
Yeah, so this is like, I'm sorry, your question is whether we keep this forever?
Yeah, because it looks like an architecture of the system, right?
Yeah.
And you need to update it probably as you change.
Yeah, of course. This also gets changed as needed. So when we have new requirements, we may make some room here, add the new screens. We may change a lot of other areas, and we have an A/B sort of comparison. Then we can see that some of the slices we have to redo from scratch. Some might be just an extra field, so we'll throw it in for free. And then of course the new ones are also going to cost, but the client appreciates knowing exactly what that change is going to cost them before they say okay. Whereas in the agile thing, we kind of say, it looks like an extra large t-shirt size. And someone can argue, no, that's only a large. That's crazy. These are subjective ways to do things. We only size things based on empirical evidence of what previous projects cost in terms of time and effort. And so we decided to make each slice cost the same amount. And that's been like that for years. So the collaborating part, which we got onto, which is great, I think it's one of the best contributions from Alberto and event storming, is really having the right people in the room so that you're not upsetting a designer, a UI person, because they're not there, and you make something that's ugly and they're going to hate. You're not going to upset an architect that's going to say, that's silly to have all these microservices. We should do some sort of a monolith. These days, right? Sorry, I know it's a Microservices Meetup. I'm sorry. So, yeah, having the right people there is important. You want the developers to be there because they don't want to get handed something that they hate. You want the testers to be there. They don't want something that will be built that they can't imagine how they will test, etc. Support people need to have an idea of where they're going to be able to look when there's a call coming in about a support issue. So all of these roles are important. So collaboration is quite good. These little things like the screens, the events, they're all plain English. So anyone can use them to participate. I think we're running a little bit long, so let's go through here. So how we start these, it depends. There's a couple of different ways. In my blog post that I wrote originally in 2018, we start by brainstorming, kind of like in event storming, all the possible things that could happen in the system and call them events. But we also know that a lot of companies start with the wireframes and the mock-ups. So we also allow that to be part of the brainstorming piece. A mix of the two or one or the other, they're totally fine. And from there you start to build out the diagram that we saw before together. So this also gives you the responsible architecture because you have to show how you have item potency. Sometimes through here you can explain to a business person that, someone can cancel the same order twice and that's okay. We'll let them be canceled twice if they're worried about some of these types of requirements. So you can get across a lot of technical concerns over to the business side using plain English. And yeah, that's about it. Any questions, just interrupt me. So one of the other things that we have is this idea of process things. So just a good example of this is like sending a message to one user, from one user to another in a dating site. So one of our clients was Plenty of Fish, which is a very popular dating site. And to send, as a public-facing, a free service, right? So sending a message from one user to another is not 2 slices. It's actually quite a lot more, right? Underneath, you have checking for spam, checking for bad words, checking for substitutions of letters, like the letter S with a $sign and things like this. So when we actually did event modeling for that requirement, there was 12 or 11 or 15 different stages, and all of these were these little gears. What you can imagine these gears being is like when you do something non-trivial in your application or on a website, when you click on a button and you get a little spinning circle, you're wondering what's going on in the background, you can bet it's something like this. Some things are being done for you, some calculations are being processed, and then at the end you get the message on the other side. So we don't really have anything like a special way to do this. Essentially, this would be the same if this was done manually. So some person could see a screen and press a button. But a lot of the things that we do are automated. So processors basically work off of this. So here it's payments to process, they get it sent, etc. These are common tiny patterns that we have. So we really have only 2 patterns of getting information into the system, showing the information coming out. And those building blocks do everything. So we don't really subscribe to any of the 50 different patterns you might have. We haven't used any of the patterns in, well, maybe by accident, but certainly not when we're talking about solutions. We never talk about any design patterns.
So I have a question.
Yes.
So what you actually describe on this diagram, you have user interaction on the top, you say what information they input, what information you send back, and you have this layers, you have at least 3 layers in the diagram. So what are the 3 layers that you, the first one is interaction?
So the layers in the event model, it's kind of like a sandwich. The middle with the blue and green marks the areas where your information's coming in and where it's coming out, and the shape of it. The top is always the users, what users see. At the bottom is state. So how you show how many subsystems you have is you show where the information is stored. So these will always, if I have 3 rows here, I have 3 subsystems. Any kind of processing, whether it's human or automated, is shown here. We show the processor in the swim lane of the user that's being affected by that delay. But the actual implementation stays tied to this service. So this green box is actually going to be implemented and deployed to where this event lives. And likewise, the logic that someone's going to implement for this blue box is going to sit here. There's a lot more about that, but I think we don't have time to explain the details. But stay behind if you want to ask me about it. So multimodal design, we kind of talked about having different views for different purposes based off the single source of truth of events. Allows us to really decouple. We are really in love with don't repeat yourself in this industry, but the evil side of don't repeat yourself is the coupling. But it's not just the data coupling and the processing coupling. It's actually the coupling of the effort of the different people that are going to be working on those pieces. And that's that coordination, that I am now walking on eggshells because I don't want to interrupt the work of these other 3 people that are sharing that one abstraction of order. I'm less likely to change it because I'm afraid that I'm going to interrupt work that's already going. That's a horrible way to get work done. So we would always rather repeat things unnecessarily in order to decouple people's effort. And that's allowed us to keep a constant cost curve to development, no matter how large the system gets. Yes, you have to copy more things, there's more duplication, but that's a linear price compared to an exponential price in coupling. So we'll always take that. So yeah, this is just 2 core patterns. The rest of the stuff just simply confuses us. Like how many more interpretations do you need about observer pattern? Like someone might get it wrong, or are you sure that everyone in your organization studied all 50 properly to apply them? If you have so many design patterns, do you have good enough numbers on how long each one takes to implement. You don't, because you're spreading your effort over so many different types of patterns. So that's why we only have 2. Now we have really good numbers because we're only doing those 2 over and over and again. And so when we look at the average, we have a high probability of being right with our estimates. So instead of patterns, we'd like to look at templates of little pieces of event models. Like, hey, we need to have a sign up in the login piece. I can just copy that from another project and quickly tailor it to fit what we're doing now. So we quite like the idea of a template more than the idea of a pattern. Testing, I already went over some of the ways that we have permutations of data, but your testers, whether it's unit tests by developers or whether you're setting things up in QA, history of events, what does that view look like after these things have happened? Add another one. What's the difference? The tests are quite easy to follow because they build on previous events, and you can very granularly understand how that implementation is supposed to go, and then of course just test that it works that way. This has a big impact on TDD because your test-driven development now is forced to be in a very narrow window. It has very small scope. So we don't actually do TDD because there's not enough room for TDD. The refactoring part is too trivial. It doesn't affect a lot of the solution. And the definition of refactoring doesn't really fit in what we're doing. So we do test first, we do test last, and those kinds of things. But that whole idea of the Ron Jeffries bowling ball game just doesn't apply. For state transitions, we have a given when thens, of course. So given a certain situation that's marked by events happening, when we send a command to change that, we get an error. In this case, we have success. Success is marked by asserting on a resulting event and its contents. So we can have lots of those, and we blow those up down below. So it's needless to say, but we do things quite a lot differently than other companies. But it's allowed us to do some incredibly awesome things and some very controversial things. So some of the things that I thought were really important in software development, I entirely reject now. I ask myself, why was I doing this? So we dropped, as I said, test-driven development. We dropped ticketing systems and backlogs. We dropped any ceremony meetings. We don't hold any stand-ups. We don't do any retrospectives. We don't do any planning sessions. We don't do anything that most companies do. We stopped caring about code quality. We have no code reviews. We absolutely don't care. Yet the solutions we produce are the highest quality I've ever seen. Yet I haven't done a code review in a long time. I haven't done any interviews, maybe 1 or 2, as far as I remember. But we just don't need to because the slices either work or they don't. The only passing criteria is that the memory doesn't blow up, it responds in enough time, and leaves the state as described in the event model. You can have, 2 space tabs or 10 space tabs. You can put your semicolons all the way at the very right margin of that to get them out of the way. You can do nested ternary operators. I don't give a damn. Doesn't matter. You can make the ugliest code and you can work for us if a solution still works. The reason we can do that is because no one has to look at your code to get their job done. What a novel concept. So instead of trying to get everyone to be a super duper developer, why not just make it irrelevant? So we don't care that the other guy is writing really ugly code. Oh man, he loves white space. There's 1 statement per screen. So fun to read. We don't read code. We never have to, our code doesn't have to be legible because we always go to the event model. That's enough to understand what's going on. No mocking frameworks, no sagas or middleware or message buses. We cheat and just subscribe directly to another event store of another service. Logically, we put in the anti-corruption layers inside the other service. Physically, it really doesn't matter where that processing is being done. Unless it has some processing impact, then yes, we will probably migrate it, but why optimize prematurely? So, interestingly, we reached the goals of domain-driven design and some of these other awesome practices without ever reading a single page of those books. So if you want to do DDD in your organization, and you don't want to force everyone to read Eric Evans' giant book and Vaughn's giant book and the other green book, do this, you'll get the results you're looking for, and then they can read those books in their spare time and go, oh, right, I got the same thing, good. So, yeah, we worked on fixed costs as well, because that was a litmus test for me. This company wasn't going to exist if this wasn't true. And the only way to really put my money where my mouth was to show that this approach would continue to work and we would never go broke. That we would continue to be able to charge the same price for all work, no matter how large the solution gets. And we made some pretty gigantic solutions. And we never suffered an exponential increase in costs. In fact, most of the work that we do near the end of projects is dead easy, like login screens and some silly reports. It's quite the opposite. We have a cost curve that goes down. We actually have less effort as time goes on, which is crazy. I thought that would never happen. We can do stuff for technical things. This is a visualized debugging of a template being filled up by Hugo or something. We extend legacy systems, which we have a couple people, well, we have Rio that's doing this, and we have others that are dealing with this, but this is how you sidecar with change data capture from the old system, event source your new system, and do a write back listener to adjust any fixes that you do in the new system that affect the old system. So we do event modeling for these situations as well, where we have to help legacy code integration or migration. We never really advise on the complete rewrite. We want to freeze what the old code base is doing and extend it, and do workarounds for the data problems that it may have. We do polyglot development, since events are kind of tying everything together. We can have certain things in .NET, certain things in Golang, certain things in PHP. We give little icons to who's working on whatever other platform they're working on. But together, it all makes sense. So the end user doesn't even know that they're looking at a page that's served by some other framework. Of course, you have to pass along your tokens and make sure that they're understood by the other stacks and that they're put somewhere where both sides can read it. But that allows you to then hire people that are good in the domain and not reject them because, oh, they don't write Ruby, sorry, we can't hire you. You're really good at trading and we could use you here, but sorry, you have the wrong stack. It's a horrible way to reject really good candidates. So there's a way to actually leverage this to make sure that you can hire the best people, and if they're using a different technology, they can still contribute without any expense to you. So some of the expert stuff in event modeling, cross-entity and variants. Some of these other things are possible. In this case, we can have something like making sure that overall outstanding orders don't go over a certain limit. The idea is that you can actually have a read model be part of the command to make sure that the validation actually goes across not just this particular aggregate, if you're using domain-driven design terms, that it also has the current state of everything else outside. You can show these things quite easily. You can show things like tombstoning or snapshotting in event modeling quite easily as well. That's only relevant if you're getting into those problems of streams getting too long. You can show those. So it's called closing the books. It's what your bank does at the end of the month for online transactions. It's what a trading company does at the end of the trading day. Next trading day, they don't care what happened the last day. It's snapshots of the starting balances at the very beginning, right? Taxation usually ends at the end of a year for doing current taxes. You might have 7-year aggregates left for prosperity, at least in Canada, 7 years. So you have these natural ways of closing the books. Your bank statements, you might have to pay $50 and wait, a week or so for them to get the archives of your old Visa statements because you're asking for 3 years ago. Why don't we do that in software, right? We shouldn't have everything online all the time. So this allows you to make sure that your footprint for your active system that's running is as small as possible. You use those expensive cloud SSDs to just have the site running really fast. You don't need the person that might ask for that record from 5 years ago on that same SSD. It's a little bit trickier to apply the same thing to read models. This is the trickiest it gets when you have something that's doing aggregation across multiple entities, i.e. for every entry in a read model that is doing aggregation across entities. You need to be really careful as to when you cut that off and how you spin it up again. But event modeling can show you how you do that for your particular business. So AI. What interesting thing that you saw here was that we have small little steps called slices, and they're the same thing over and over again. That's really good for training data, right? For training these large language models. It's really good training data for AI. So why not use that? I've tried it. For me, the more interesting thing is not getting AI to generate the code from an event model. The more interesting thing for me is recording a conversation about your services and products and taking that transcript and having AI draw you an event model. Oh, it seems like your business would need to show these screens and store this information. Do you want to start there and start to edit that? That, I think, is incredibly powerful. I think we're already at the point where you can take something like an event model and say, generate some code. We're actually very close to that. That's not that interesting, and there's going to be other case tools that are going to be firing off quite fast in terms of AI. In fact, we're already doing that a little bit with the prompts in some of the things like Copilot and Cursor AI and other tools. So that's not that interesting. The interesting part is taking how we discuss our business together and have AI eavesdrop and give you a blueprint of how all that stuff's supposed to work. So, basically, I said, give me an online store or something here. But it made some problems. It doesn't understand quite well what slices are. So it added a whole bunch of things like multiple events into one slice. So you can see I had to really prompt this. So multiple slices, each slice focuses on one command or state, or what's it called, view state. I think I made a typo there. 7 times after, it finally it started to understand. But look what it got. It started to finally see that you have one UI piece, you have one command. It's starting to add example data. It's understanding that there's 2 types, state change and a state view. It understands that in a state view slice, you start with the green box and go to the UI as the arrows go up. So even though it's pretty rough around the edges, I was quite surprised how far it got.
I have a question.
Yes?
Did you use the GPTs and the GPT-4 model? So you essentially can give him instruction about how he should behave.
Yes. Yes, I did. And in fact, it was a refined model by Graymore, which was made for coding already. So it had initial refinements to be specifically built for technical solutions. Although the problem with AI is that it's trained on a lot of data that is CRUD applications. And so it'll make mistakes like calling query best price as a command. Right? It'll make those stupid mistakes that if you're doing event sourcing, that's the first thing you correct with a lot of people that are doing event storming or event modeling exercises. That you have to correct them. Okay, this is not changing state. This is not a command. You're just looking at a sorted list that was, populated by events. So it's as dumb as the person you pull off the street. So, yes.
I mean, exactly what I see from this example is that you knew pretty much what you wanted it to say, right? You tried to talk it into saying what you wanted to say, and it still took 7 tries. So if you embark on a journey where you don't,
It's a little bit more. That was the refinement of one of the prompts that I had to give it. So it was a bit more than that.
If you don't know where you need to go, and you're open exploring what is now a good event model, how close do you think you are to that? I don't know. I think I'm using it, and sometimes it's good, and sometimes it's not. But
I think what we're really needing to look at is whether some of the stuff needs entire models trained, or whether we can do the refinements and give enough example data to that. So I'm currently using private GPT to, first of all, we need to do that for a lot of our clients. A lot of our clients will not allow us to use ChatGPT, for example, or other online AI tools because of their fear that their IP is going to end up in some training data that's going to be leaked out at some point. So we've had that specifically asked of us not to use AI tools during development of their solutions. And this is one of the reasons I'm using private GPT on this computer to start to look at, what's the gap between what OpenAI provides versus what I can get from some of the open source things that I can run on the computer here. Because if I can get that more or less close, I'll definitely be using that. And as I refine more things, I mean, it's so predictable what we're doing, always blue-green boxes, that we have a ton of, like maybe 12, a handful or two of scripts where we just type in the event name and this is probably what it needs. So it auto-generates so much of our solutions, and then we're just filling in the scaffolding with the proper information, proper tests, proper logic, and go from there. So it's really, this is the closest I've seen to a true software factory, and I think focusing on state makes it something that's attainable, because everyone says every solution's a snowflake, but you know what? We actually are doing boring stuff. Most of the things that we're doing, it's another insurance company, it's another retail thing, it's another point of sale system. Most of the software development is pretty boring stuff. We're digitizing our regular world. These regular world things were all forms that were filled out and passed on. It's just kicking the ball along, more information going further and further along. So yeah, don't try and make exotic ways of doing the same thing over and over again. Right? A lot of these complex things are just described in more steps that are simple steps. So you don't want to be complicated. You want something that's complicated. You want it to be stretched out to be complex. Because something that's complex, you can look in small iterations and understand that the complexity is divided into something that's understandable, into a combination of small, simple steps that are not complex or complicated. Yeah, so there's a lot of things to do here still. Like, I didn't have the references in the slices to, for example, where this event actually was used in what read model later. So representing the arrows a little bit better in what it came out with for now, but we're pretty close to that. Yeah, so lots of ideas if you want to try this yourself. And I think it's kind of fun because it also tests you, how well you understand event modeling, because it's like explaining something to a 5-year-old. I think it's Einstein that said that. You don't really understand a subject until you can explain it to a 5-year-old, right? So, same thing here.
Feynman. Richard Feynman.
Was it Feynman? Yes, Feynman. One of those smart guys. That's right. So, fun for hackathons. We've seen really good results where people win entire hackathons if they take that 1 hour to plan and to design, even if it's rough. It allows you to use that slice approach to say, okay, you work on this, you work on this, you work on this. I have high confidence that it'll click together. Mostly hackathons is people trying to go as fast as possible, and there's a whole bunch of mistakes and rework that they add. They drop too many things. This little bit here in a hackathon is going to go so much. If you have hackathons at your company, definitely do this. Even if you don't do event modeling, do something here. Don't just start hitting the keyboard. But event modeling is quite good. A fast way to get event modeling done is just to write down the screens, design the screens, and just put down the events. But make sure the events are filled with properties and actual example data. If you just do that, you have 80% of a complete event model, and you'll get much faster and further than other teams. So that's a cheat code there. Event modeling has a neat history. It had hit the top story on Hacker News. I remember getting surprised by all the alerts on my phone that day. Someone decided to put it up onto Y Combinator, and it got the initial post got quite a notoriety. So a lot of people noticed what it was, and then it started to spread without me. I was lucky enough to correspond with Fred Brooks, who read this before he died. He's the person that is behind the Mythical Man Month and the whole idea of a state being king and understanding systems. So I had a small interaction with him, it was one of the highlights of my career to actually be in contact with someone like him. Other people that are using it, they say that things go incredibly well, things go pretty fast. So people get blown away with the results because they're used to seeing traditional, boring user stories, use cases, a lot of text and wikis getting filled out and Jira tickets getting filled out. So when they see something like event modeling, usually they're very pleasantly surprised with how much value they see and what they know about the system. Also, Vaughn Vernon had nice things to say. He's one of the biggest forces in domain-driven design, etc. He said that learning about event sourcing and domain-driven design is a lot easier because of this. So Vaughn's also a big fan. He did a really large workshop with me a couple of years ago online during COVID, which was really fun. Maybe, was it 2 years ago, 1 year ago? I forget, something like that. But yeah, he's been a big proponent as well. So if you do it, it's really fun. So if you want to join the discussion, there's a Discord group that people from all around the world go and discuss this. There's an event modeling Twitter account, which doesn't have some of the other controversial stuff I tweet about, and just has event modeling tweets, if you don't want to follow me. And of course, especially during COVID, I recorded a lot of videos of doing event modeling, explaining event modeling on YouTube. So if you search YouTube for event modeling, you will definitely get a lot of material to go through. And so a lot of places that are trying to put event modeling into their organizations go through some of these videos, and people in the companies watch some of them. Some of them will get a little bit long, so you can put 2 times speed or 1.5, because a lot of them are meetups like this where we're doing hands-on event modeling for sometimes 4 hours. I just decided to capture them all and record them, especially since everyone was on Zoom during COVID. Just hit the record button and put them on YouTube so people could see what's going on. So yeah, I think that's it. Thank you. So I think there's a few questions, or is it all clear?
Yes, thank you, Adam. And now for the question. Let's start at the front row. Don't have to run.
I've got first, thank you very much for your talk, as usual. I've got a very fun topic, security. How do you deal with security when you say you don't do code reviews, you don't care about the crappy code people write?
Yeah, so security is something that we have a partner company called Forward Security. They actually use the slices to form threat models because they understand how the APIs are used in what order, and example data is there. So it actually gives them a head start on trying to think about threat modeling. But yeah, maybe I don't care about the code, but some of the inspection tools that are in the pipeline for CI/CD will say, yeah, there's some problems here. You got some outdated dependencies. You got, you know, some bad things being handled with private data. Maybe hashing is being done wrong, or maybe you're not using a special type for passwords, which could leak them in memory and things like this. So, but most of those types of checks are automated, so it hasn't really affected us. What I'm talking about is code style. Like, I hate how you code, and you hate how I code, and all of a sudden we have to merge our two efforts. Like, right? It's just, you might as well have a fight outside. It's just, it's horrible. So the merges never actually come up as two people merging their same code for getting features out. And that's actually a good thing. So we don't want people to be insisting that they have the better way of doing things. I personally hated A and D in C#, you know, where the opening brace is on the next line. I can't stand that. I thought that it loses too much context when you're merging. So I always liked K and R, the original C, you know, brackets. That was a lot better for me. So. But then again, you look at, for C# especially, was kind of a real pain, because they're the ones that deviated from all C language style that's out there. Everyone had K and R, and then they did .NET, and they used A and D. So everything's built for braces being on the end of the line of opening the block. And then here you have Microsoft stuff with a stupid thing on the other end. I'm like, why, right? And so entire projects like Mono project to run .NET on Linux was K and R. All this stuff that Microsoft's putting out was A and D, and then you're trying to copy code, and anyway, a nightmare. So I don't want that to be in the way.
Okay, but you don't have any methodology statement, so it's security external.
Yeah, I used to be very picky about, like, write code that's concise. I hated excess, white space. I thought that was really bad for trying to get merges done properly. Context areas were bad. They didn't have information. So, but now I don't care. So I'm happy.
So, I will go back and forth. Front row, back row.
Hi, thanks for the talk. I was wondering, as I know a couple of companies wanted to keep their code maintainable, on how many different code languages you would recommend. I don't know if you have statistics like stable prices for your slices, if you also have like recommendation on how many hundreds of employees or developers, how many different languages you would recommend.
I don't have an opinion on it. One of the weirdest things about this is that maintenance is entirely different. So we're rewriting entire slices when something changes. The only time that we really revisit something is if there's a bug and it's the same developer that goes to do that, because to do fixed cost, we have to pay when the slice is finished. But the other side of the deal is that if there's a bug, that developer has to come back and work on it. They don't get another slice until this is fixed. So there's a natural incentive and a disincentive, which keeps the code quality high throughout the whole thing, because no one wants to be stuck. Like, if I go fast and I write 10 slices and they're really shitty, then I'm fixing bugs for the next 2 weeks and actually hurt myself, right? I don't, until all those are done, I'm actually not earning money. And so that's worked incredibly well. It's allowed us to see just the difference in abilities of a lot of developers. We don't have to worry about salaries because everyone gets paid the same price for each slice. It's like a junior person will get, one slice done in 2-3 weeks, while a senior person will get 2 or 3 of those done in 1 week. And that's actually what determines the rate of pay. Surprisingly, everyone's really happy to get paid that way. There's no secrets of who makes what. Everyone's playing by the same rules. There's absolutely no discrimination, no subjectivity. I don't care if I like or hate that person. They have the right to work here. When their work is done, they get paid. It's entirely unsubjective. So for diversity and all that other stuff, it's really good. But also for maintenance, the ability to just replace a slice is really good. And if that slice is in a different language, that's fine. It also depends on like, okay, maybe if it's different JVM languages, maybe that's easier versus having something entirely alien, like you're doing Python here and then JVM and then .NET, you're mixing three. It may be fine, and especially with things like serverless, it might not really be a big deal at all. If you're implementing this with serverless, why would you care at all? I mean, I hope that answers your question, but you have to try it out to see how it works first. Yeah.
Thank you, Adam. It's very convincing. I think the anonymous online versions of your talks are much less convincing than seeing something like that. And it seemed I really like the human aspects that you said also in the beginning, and that is also the motivation behind extreme programming and event storming. So it seems like it's extremist programming because you're very dogmatic on keeping it. I have many questions, but I'll just only ask one, which is, but you probably just answered it. It doesn't really matter. But I think the slices can be implemented as actors, which are a bit more lightweight than the services that you've shown.
Yeah, the event model has no opinion on implementation.
Yeah.
Absolutely. So yeah, no, actually that's not true. Yeah, a lot of people use this without event sourcing because it's just a good idea of representing what facts the system captures.
Maybe that answers also like the next questions. Can you gradually adopt the ideas?
Yeah, absolutely. You can, and in fact, we've even had an event modeling session for building a mine. It's the deepest mine in Europe. And it was event modeled, building of them. They didn't build software with the event model, but they used an event model to understand all the processes that needed to be in place for the creation of the mine, which included a 50-kilometer conveyor belt, continuous conveyor belt underground, because the mine was surrounded by a park. So they couldn't take trucks through to get all of that stuff. So I think it's the longest continuous conveyor belt in the world as well. It's somewhere in England, in Whitby, I believe. Yeah.
Hi. Hello.
I don't have power, sorry. Not sure why it's off. Go ahead.
Yeah, thank you for the talk, first of all. I have a question about what you said. Each slice owns its own data and are the source of truth. But then you also said that it's okay to duplicate the data in different slices or by different services. Is there an opinion about should you duplicate data, or do you have one source of truth for one kind of model?
So the source of truth comment is really about when you have state change, that is new information entering the system. And that is what's not subjective. It may be subjective if you're maybe doing something like collaborating on whether this form for sign up should include some fields or not, and whether you're going to ask for that information once they're already a signed up user. But once that decision is done, you are now at the mercy of the fact that you're capturing this information at this point in time. That is your source of truth, because you've made that deal now. Your system will act by absorbing this information at these points in time. Those facts are now not disputed. The problem with a traditional approach is that you may start to make triggers or add default information to other tables. You might have different opinions about whether this user object has inheritance or not for other things. All of these things are subjective, and a lot of times we get into fights with the armchair architect, the ivory tower architect that's going to tell us how to build our systems. They might draw some UML diagrams for us, and then we have to trust that person that they had the better idea, and maybe they quit and you get a different senior developer architect and they have a different idea of how you make your user object and how the tables should be structured underneath. You see there's subjectivity there. If you do this, you at least remove that. And what you're doing is allowing people to have, maybe we can just kill the projector because I lost power to this outlet here, so my laptop's dead. So anyway, the source of truth is easier when you look at data entering the system. What allows you to be more subjective is when you're using that data to drive further information when you're making projections of that. So I can have many different places in my workflow where I'm presenting user information. And there I can construct out of any pieces of data that got gathered whatever I want for that view to be. And so maybe a profile page will have a profile pic. Maybe another admin page will just have a list of users. You don't need the profile pic there. What I'm saying is that you go ahead and repeat some of that information rather than join the same table. Because if you join on a similar table and you have to work through the solutions, and one person's working on the profile page, one's working on the admin page, you're coupled and you're going to have to coordinate with one another. That coordination is extremely expensive. The other person could be on vacation. They might be in another time zone. They might not be available right now. Whatever it is, you're coupling effort of people. And I think that's the worst kind of coupling. It's the fallout of the technical coupling.
Yeah, just to clarify, this generation of state, when you're using the data from some other slice, this could also result in added latency in some services.
Yeah, it hasn't hurt us at all. After hundreds of projects, the whole idea with CQRS and eventual consistency being a problem, we've over and over proved that it isn't an issue. Things are so fast. The only place where we've had eventual consistency come up is a real, like a trading system, an actual cryptocurrency exchange, where in order to combat the eventual consistency argument, you needed to switch from event sourcing to ledger sourcing. The only difference with ledger is that you are publishing events that have extra information on there, such as the current balance. So you're using accounting ledgers instead of events that are facts. And you're only doing it on purpose to remove that extra round trip. But it's fine, and you do it in 0.01% of the solutions out there that we had is just, that's where it happened. And the rest of the solutions never really suffer any eventual consistency issues. In fact, a lot of the stuff that we write, most of the trip from the UI through the blue box to the orange box to the green box to the next UI is done in one web request synchronously, and we don't care. That's fine. A lot of the processors that you may see are async. After you update that green box table, you immediately synchronously call the process that's supposed to act on it. So you're not even using any pub sub stuff there. You're just inlining it, and it's fine. I don't think many people really realize how far you can take reversing the premature optimization thing. You can take it to quite an extreme. And we should all do that just to understand how simple things can be. If I show you the simplest event source system, it's really, here's another difference. Event source systems imply CQRS, but they don't have to have CQRS from another perspective. You don't have to have materialized views. CQRS says to never query the right side. But event sourcing doesn't have that rule. So that's why I say we do event sourcing, because there's plenty of systems where I read the events, plain and simple, violating CQRS all over the place, and things work just fine. Depends on your SLAs and whether that's actually some real-time trading system. But I guarantee you 99% of the systems out there are not real-time trading systems. They're your boring insurance companies, your point-of-sale systems, etc. And they work just fine by breaking these rules. Number one rules you don't break is store the events this way. Keep the data like this. Keep multiple projections instead of trying to lump them together. Those are going to hurt you. The stuff about this being async or don't read the events, that only crops up if your SLAs are in trouble. And for most operations out there, our hardware is so fast right now, these eventual consistency stuff and all these other things don't pop up, ever. But at least for us, it's never really an issue.
I can only confirm that because I had a system which had actually 3 languages, as you said, yeah, like Ruby, Java, and .NET, and we had this kind of similar approach. And I've noticed there were some problems, like I felt that this was a waterfallish project because you had to start with modeling the whole flow of the user through the different systems. And basically, if you're trying to build something new product, and nobody knows how the user would behave, what would be the steps, and that seemed to be like a big overhead. And I think it slowed us down, and it took much more time than, let's say, if we would just try to do it iteratively with something simpler. This is one thing. And I think the second thing, the company invested so much money into building the schemas and to make sure that these different components could read the same events. And I saw that, yeah, this is really cool, you have these events, but then you have different type of problems like this overhead. Like, would you agree that this overhead exists and it's maybe not necessarily for all the project to have
Are you talking about the overhead of making an event model, that it takes too long?
Event model and this communication between the teams, where you need to define the whole floor. And
so yeah, sometimes that might be a logistics issue if you have a large team or teams in different places in the world. But generally, it's 5% of the effort goes to event models. Maybe we're just really fast at it because we've been doing it all the time. So we generally will have something as short as one afternoon to do an event model of a core component for a proof of concept, but that's pretty much implemented by Wednesday. We're showing them that proof of concept working. So I haven't seen it as a large overhead. I've seen resistance to doing it, and maybe that's what some of it is. What you're talking about is that people are like, well, I'm used to doing things a different way, so they drag their feet going to doing something a different way. So there's a lot of adoption issues still, especially if this is something new. For the largest systems that we've had, like the trading system was non-trivial. Yes, you go back to refine, but they all understand that that's erasing a lot of other meetings. And maybe we just have a blind eye to how many meetings regular projects have, that it's just accepted. If you were to actually calculate the unnecessary communication, I think planning, whether you're doing event modeling or not, maybe you're doing UML with sequence diagrams that are not as fine-grained as they are typically, you would probably have the same result, that you're going to have a solution that has less rework because people are aligned in terms of where they're heading to. Maybe you had a problem where event modeling or something like it was specifying the implementation, which is a lot of problems that I find when people are adopting event modeling, is that they're going into how is this going to get developed. They're not focusing on event modeling just telling you where the information goes at what time by example. They're worried about, is this a webhook? Is this a Kafka? What is this here? Don't answer that. Just track the information, and then you'll get through your event model faster, and you won't be stuck documenting implementation. This is not to document implementation. This is to document information flow over time so everyone knows what the goal of the system is. If you're doing the details, you miss the point, and you might as well be doing UML.
I think the problem was that each slice wasn't bringing any value by itself. You have the value when you have the whole floor, and to do that, you basically need all of them implemented, yeah?
Maybe that's the problem. Maybe someone took it too literally, that you have to have the whole thing modeled, because there's definitely places and projects where we model the first 20%. There's places where we model almost in an agile sense, and all the client wants is a good unit of work to pay for, because they've had projects that were time and materials where they got taken for a ride on a very long tail of like, oh, it's almost done forever. At least this gives you specific steps that are done, and you have a fixed cost on it. So I think that may be one of the issues. So generally we want most of it to be done, but we don't ever say that it's 100%. We want 100% of the systems where we have to do the completeness check. If there's some critical issues, like the trading system that I was talking about, that's where we would do that. And that was, it wasn't that bad. In 2 days, we got to actually model the New York Stock Exchange with about 300 parameters under API calls. They took another couple of weeks to make sure that there was information complete for the rest of the areas where there was problems, but they needed that to finish that project. Maybe if you're exploring, maybe you don't do event modeling. Maybe it's fine to do agile in some of the projects if it's total R&D. I don't know. It simply is not a big overhead for us. In fact, we don't charge for event modeling when we have a contract. It's something that's included as part of the price of the slices, that we just end up doing this for the first week or the first 2 days or whatever it is, depending on how large the project is. So we better be done with it quickly, because we want to make sure that we're actually implementing it and that we're not adding rework. But we can discuss maybe your specific topic after, offline, if you like. One more time for other questions, if there are any.
Yes, I think I have a last question.
Sure.
It's you gave the metaphor of it's very similar to like working at a construction site, that we try to like decouple all the development stuff. And you also mentioned that you try to avoid code reviews and like being more pragmatic in the development, if I understand correctly. But is there no like risk associated to it if you like look later, if the house is built and you maybe recognize that some of the parts in the house are not properly built because of like lacking code reviews and ensuring, yeah?
I think the analogy is a stretch anyway, but I like to use it because I don't like rejecting that analogy. I think people want to say software is a lot softer than real world, but it's still costing you time and effort, just like putting bricks down and all that. And in fact, some of the stuff in housing is agile, but on a year-to-year base. Like people add extensions to houses. They have to replace pipes after a while, and etc. Interesting thing is that they do have schematics for that. They do have blueprints for that. I don't think software is built for free. And so whether it's your time and money and effort, whether it's bricks and concrete, I think they're fairly like they're not free. They cost money and time. So I think it's a valid comparison, especially if you're going to be doing not purely reactive work. You're actually modeling enough so that you are not constantly changing your mind about how previous parts that you've already written have to be adjusted. A lot of it is, you know, I don't think it's stated enough how important multiple model paradigms change the way development is done. The biggest difference between an event modeled system, which has a lot of these green boxes that are purpose-built, it hinges on people using multiple models instead of trying to make everyone agree on one model. Like, oh, there's only one view of an order. That is incredibly high amount of coupling for work and otherwise. Just solving that problem. You don't even have to do event modeling. Just solving the problem of getting rid of unnecessary coupling is going to save a lot of this rework and revisiting code. Like we talk about open-close principle. The fact that all the slices, you don't have to go look and double-check and redo something on the previous one that's already been done. That's, in effect, a form of open-close principle. So that you're only adding. That is the essence of not having rework, of having constant costs. That's what's missing in the industry. It's not because of event modeling. It's because of not trying to make one model work for everything. That's stupid. And most of the world doesn't work like that if it's not digitized.
One in the back.
My question is about API design. So do your slices directly expose the commands they are able to handle, or should there be some translation involved?
We only worry about that if we're designing that to be integrated with a third party that's not us. Internally, our APIs, we really don't care about the implementation. They're an implementation detail. For external stuff, you would really, you're at the, I mean, we were discussing this earlier before the meetup actually. You would really hold yourself to what people are expecting of public contracts, and we would design them the same way. I think there's an argument to have a translation layer to keep the churn that you may have inside your solution to not bump the version all the time on the public API. One of my problems with APIs anyway is that they're all very resource-based and cruddy. In other words, you're always updating or deleting or inserting something like you would in a CRUD application. And we all know that that's not how, you know, systems are supposed to be done. That's why we're here. We're talking about domain-driven design and all these other things. We really want the intent of behavior to be captured, not just changing rows in a table. So I think that's a bigger, very hard question to answer, because there's an inherent problem in the industry of how it's treated in general, that I wish there was an alternate paradigm that was embraced as much as REST is. But unfortunately, that's not the case. So if you have ideas, let me know.
So one final question. So there are many arms open. You were very early in raising it.
Yeah, so thanks for the presentation and explaining, answering the questions. My question might not be relevant, but is it any common area between this event modeling and business process modeling?
BPMN?
Yes.
Not really. I mean, there is a few. The fact that business people can use this is the common thing. BPMN kind of drops off because it doesn't have UX as the core component. It doesn't have the storyline where it's specification by example or BDD. Event modeling is in the style of behavior-driven design and specification by example. You don't have forks of data. Like in BPMN and activity diagrams in UML, you have all the forks and flowcharts. Flowcharts and forks and graphs are hard for you to remember. Humans like stories, right? A lot of times when you listen to my presentations, I'm talking about children listening to stories, and then as adults, they can say the same stories to their children. This linear way of having keys, key places and stories and facts is what makes civilization succeed. We're the first species to pass our memories to the next generation by storytelling. Every culture is where it is because of storytelling. It's how our memory is fixed, how language works, and that's why behavior-driven development is successful with specification by example. And this is building on top of that idea. That's why this event model shows architectural goals and information architecture goals through keeping true to what makes humans communicate better. I hope that answers your question. Yeah.
So thank you very much, Adam. You stick around
for
beer and answering more questions. So just gather around him. Beers is still over there. Stay for small talk and conversations, and hopefully we'll see each other again, perhaps with a non-event sourced event model microservice meetup, but I cannot promise that.